we're going to go through points, lines, and planes. And actually, these are the first three things that I'm going to write down in my term descriptions. That's what we're talking about right now. Points, lines, and planes. These are the three things, the basics of geometry that build up everything else. So if I'm naming a point, I'm always going to name it with a capital letter. As you can see right there, it is a capital letter. That is point A. Now when I'm naming lines, I'm still going to use those capital letters if I'm defining it with its points that it's made up of. For example, this line is made up of points P and Q, so I can actually name it with those. And that's the more common way of doing this. People look to the lines and figure out what points are on there and then define it that way. So if I'm naming this one, I would name it PQ, and you could also name it QP. It doesn't really matter the order, but I'm going to name it PQ. And then to show that I'm talking about the line and not the points, I'm actually going to draw the line on top of it. So that's how you would write your final answer if I asked you what that line was, PQ. You could also call it, well, maybe I should write it this way too. You could also call it QP with the line over top. It doesn't really matter. I prefer to go in alphabetical order, and that's the way you're normally going to see me do it, but either one works. You could also name it line M. Now, this is a lowercase letter, and it's not, and the reason for that is because it's not a point. It's not a point, it's talking about the line. When we're talking about lines, usually those will be in lowercase letters. For example, this one is M. Let's move on to planes. When we talked about points, we just used one letter in our naming process. When we talked about lines, we had to use two of them. So this is just 1 point. These are 2 points. When we talk about planes, we need 3 of them. I see 3 points right there, and right there. K is actually not a point. It doesn't have a point next to it. So actually, we could just call this plane K. Or we could use these 3 points to define it. So you could call it B, C, D, but you could also call it D, B, C, or C, B, D, or C, D, B. It doesn't matter which order you put those in. All of those are good. We just have to use 3 points. And those points are capitalized. And I don't have to write any lines over top of them or anything because when you have 3 letters, we just assume that it's a plane. Next question here. Brainstorm and write examples of where you see points, lines, and planes in the classroom. I'm just going to go through 3 really quick examples. The example that I use for a point would maybe be the tip of a pencil. That's more of a location and not a size. Lines, maybe the edge of a ruler. And planes, maybe the cover of a book. I guess I didn't really talk about what a plane was yet, so I should probably go back quick. Sorry for kind of skipping over that. Sometimes I forget how much you guys know. Let's talk about what a plane is. Maybe even we can talk about what a line is first. A line is something that's straight right here. This is straight, and it goes on infinitely in every direction. Now, when I say line, like if I'm drawing a line, you can't actually draw a line. It's not possible to draw a line because you can't go on in both directions forever, infinitely, unless you're drawing the arrows on the ends. Same thing for a plane. It doesn't really look like we have arrows on this plane right here. This is a plane. The best way I can describe it is like a sheet of paper. Instead of being 8.5 inches by 11 inches, like a regular white sheet of paper, a plane goes on in infinite directions everywhere. So infinitely up, infinitely down, infinitely right, infinitely left. And this one's a little bit easier to explain in person, but that's what a plane is. It's a two-dimensional object, but it goes infinitely up and down and infinitely left and right, and it has zero thickness. It's like no thickness at all. So back to what I called a plane. A plane is like the cover of a book, except it's not really, because the cover of the book doesn't go on infinitely in all four directions. But that's the best we can do. The same thing with the edge of a ruler. I can't really do that because it doesn't go on infinitely. It only goes on a foot. So I can't really give you real life examples of where these are. We can only give you like kind of examples. Moving on here. Let's talk about these two. A ray is a part of a line. It has one endpoint and extends indefinitely, or this just another word for indefinitely is infinitely in one direction. Okay, so it would look something like this. Let's do, there's my endpoint, there's my arrow, and I'm going to throw another point on there as well. We'll call it A and B. This is a ray, and I didn't do a very good job of drawing a straight line here, but it should be straight, and it has an arrow only on one side of it. How would I name this? Well, first of all, I got to tell you here, when we're talking about rays, this is very important to know. When you're defining it, you always have to draw your arrow going to the right. You will never, ever, ever see me drawing a ray going to the left when I'm naming it. Then I have to look at, well, which side was closer to the arrow? Well, that was a B. That was closer on our diagram to the arrow. So I'm going to put the B closer to the arrow. The A goes on the other side near the endpoint. This is just an endpoint that the A is on. And that's how I would define that. Let's continue. The next one is a segment. A segment is a part of a line that is bounded by two endpoints and contains every point on the line between its points. So a segment would look more like this. Two points like this, connected by what looks to be like a line, but it can't really call it a line because it doesn't go on forever. It stops there. So this is called a segment, and I would define it like this, or I would name it like that. Notice I don't have arrows on top of my letters. It shows that it's a segment and not a line. If we continue, points that lie on the same line. If I'm thinking about, for example, two pilots in the same airplane, they are co-pilots. If I talk about two workers at the same building, they are co-workers. What do you think we call two points that lie on the same line? They are co-linear. How about two points that lie in the same plane? Or two or more. Two or more points that lie in the same plane are co-planar. Let's continue. These are just some questions that you might see on homework. First of all, this one is a ray. I know because it only goes off in one direction. How would I write this? Again, being sure that I always write my arrows to the right. C was closer to the arrow on that one, and D was closer to the endpoint. So I would name it ray DC. On this one, it doesn't really matter which order. We could go FE or EF, because there's no arrows above what we're writing there. But this is a line segment. And then the line here has both arrows. And again, we could go, I'm going to do it backwards this time, BA. And that is okay to do because it's not a ray. The ray is the only one that really matters because it has an arrow going in one direction. Use the figure to name each of the following. A line containing point W. Let's see, a line containing point W. I see this line right here. Can't really draw it very straight, but this one right here. That line contains point W. If I'm defining a line, let's go up here really quick. A line, remember, we write like this. So let's go back down. A line containing point W, there's multiple ways we could do this. We could say VW, and it's a line, so I got to have both of those arrows on there. I could also do, let's do WX. That's still, we still know which one that is because it's this point and this point, so we have to be talking about that line. We could also do, we don't even have to put W in there if we don't want to. We could do something like VX. V and X are on the same line, and that line contains point W, so that would work. And then lastly, I could also do, and there are more ways than this, but I could also do line lowercase n. That's this guy right there. That's not really a point, it's a lowercase letter, and we know points have to be capital. That's talking about that line there, line n. Oops, I already had the next question answered in. The intersection of two or more geometry figures is the set of points that they have in common. Where do these two lines intersect, or where do they meet? That's at point P, right there. So this actually means we're going to go down to this next question. How many times can two lines intersect? Well, if they're straight lines, they're only going to intersect once. Two lines intersect at a point. That's what we saw. They intersect there at point P. Two planes intersecting, though, is a little different. Picture these as two sheets of paper, and one sheet of paper can somehow go through another sheet of paper, like this. Where are those pieces of paper touching? All along what I've drawn there, which happens to be a line. And it does have arrows on here, so it is a line, because these planes go out in these directions as well. So they form a line. Okay, last one here. Another name for plane Z is plane. If I'm naming a plane, remember, up here we said planes have to have 3 points. So another one for plane Z. Well, I see K right here is on that plane. I see J is on it. And actually, we can't pick 3 points that are on the same line. We have to pick one that's off of it. And so I'll pick P as well. So let's go with P, J, K. You could have done JPK or KBJ, PJ, or whatever you want. But I just went with PJK this time. Next, let me erase. I'm going with, so now I need 2 more points that are distinct points, which just means that they're different points, that are collinear. So collinear with N. N is right here. I need 2 other points on that line. Do you see 2 other points that are on that line? You should see M and L being on that line. Straight up and down, right there. Notice also that that line actually goes through the plane up and down. This dotted line means it's behind it, and you wouldn't be able to see it if that plane was not clear. Oops, I erased M and L. I'm looking for 3 more distinct points from H that are coplanar now. So coplanar, we're looking for points that are on the same plane. H is one of them. J, we could do, is on that plane. K is on that plane. And P is on that plane. You could have also done M, but you could not have done Z. Again, Z is not a point. That's just defining the plane. Suppose line JP is drawn on the figure. Suppose JP is drawn on the figure. So if I draw JP right here, then JP and blank are distinct lines that intersect. Well, which one does JP intersect with? JP intersects with HK, we could call it. You could also call it HJ, or you could call it JK or KJ. Doesn't matter the order on those, it only matters for rays. That's all I got for this first lesson.